And then, so f of x equals 4x to the 6th power minus 5x to the 4th plus 9x to the 3rd minus x.
What was the question?
How many total zeros does each function have?
Okay. How many does this one have?
Which one?
The one we're looking at.
3. No, 4. Is it 4?
Always the greatest exponent.
Oh, okay. So it's 6. Okay.
And this is just one function. When they say each function, there's more to come. But this particular function, it's always whatever variable the largest exponent. That's how many zeros it has.
Okay. So this one has 6?
Huh?
Okay. And then the next one, so if my greatest exponent in my next function is 11, does that mean it has 11 zeros?
It has 11 zeros, exactly.
Okay. Then we'll move on. Using the factored form of each given polynomial, determine all x-intercepts of the function, and for each x-intercept, state whether the graph crosses through the x-axis or is tangent.
Okay.
So f of x equals -4, parentheses x minus 9, and then to the 8th after you close the parentheses, and then new parentheses x plus 6, and then to the 5th on the outside of those parentheses.
What's the exponent on this one?
5, the 5th.
Okay.
Okay, so if determine all the x-intercepts of the function. So how would I have to multiply the 4 into the 8 or the x?
No.
Minus 9.
What we have to do is set this equal to 0 and solve it.
Okay, so
Okay. Now,
negative.
there's only two numbers that make that equal to 0. Remember that to get 0, when you multiply two numbers together, and that's all this is 3 numbers, one of them has to be 0.
Okay.
If we solve that, setting it equal to 0, what does x have to be?
It has to be. Is it x equals -9?
Not -9, +9.
Positive. Oh yeah.
In other words,
Okay.
if I were to let x be 9, then I would have 9 minus 9, 0. 0 to the 8th power is still 0. So x equals 9 is one of the zeros. What's the other one?
X equals -6.
Okay. So what that means is at these 2 points, 9 and -6, we're going to have our graph either touching or crossing the x-axis.
Okay.
When they say tangent, over here on the left, I'm going to draw y equals x squared. There's 2 zeros.
Yeah.
Y equal x squared, and they are both 0. In other words, there's only one 0, but it has multiplicity of 2. What's the multiplicity on the x equal 9?
The multiplicity on the x equals 9 is
8.
Wait, but
always the exponent.
Oh, okay. Okay.
What's the multiplicity on the x equal -6?
5.
Okay. The rule is if you have even multiplicity, which is this case over here, that is even multiplicity. The zeros are 0 and 0. So 0 with a multiplicity of 2 is even. Therefore, it does not cross the x-axis. It just touches it.
Okay.
Now, when you have multiplicity that is an even number, it only touches the x-axis. It does not cross it. So at 9, it's going to be tangent to the x-axis. At -6, it's going to go through the x-axis.
I thought you said that even numbers
Even numbers do not cross. Odd numbers cross.
Okay.
This was an even number. It did not cross. It went down, and another way to refer to that is it's kissing the x-axis. This is kissing the x-axis over here at 9. Now, what it looks like in between there could be something like that. But the fact is that it only has 2 zeros, -6 and 9. And they are, one is an odd multiplicity, the other is even. Even multiplicity, it always kisses. And if you want a way to memorize it, think about y equal x squared. Because if you solve that, if you solve x squared equals 0, you get x equals 0. Well, it's a quadratic. It's got to have 2, so it's multiplicity of 2. And if I look at the graph over here, it's not going through the x-axis. It is kissing it, bouncing off. Or as they put it, it is tangent to the x-axis. And that is what it is, tangent.
Okay.
That's the correct terminology from a calculus point of view.
Okay.
Okay? What else you got?
So the next one that I would do, it's f of x equals 5x parentheses x minus 1 to the second power, and then parentheses x minus 8 to the, oh no, outside of the parentheses to the 6th power. Oh, sorry.
Whoops, I lost you.
So, and then another set of parentheses, x minus 8, and then on the outside of the parentheses is to the 6th power.
Okay. Tell me my
so with this one, so the first zero
and multiplicity.
Okay, so the first zero is 1 to the.
Actually, it's not.
Is it x?
If yes, if
it is
0,
x.
The whole thing is 0, regardless of what else. If x is 0, that makes the whole thing 0. If you are multiplying numbers together and one of them is 0, they're all 0. I mean, the answer is 0. So x equals 0 is 1. What's the multiplicity on that?
To the second?
No, there's only one of them.
Okay.
In other words, I don't have 2 zeros. If that was an x squared, then I would have, if that was like that, well, then the multiplicity would be 2. But the only 0 I have is x 0 one time. So it's multiplicity of 1. Next 0
is 8.
No, well, let's go in order. Let's go left to right. Always use an order and stick with it. It makes your whole process more methodical.
Okay. Well, I thought I would just switch the sign on the number, and that was my 0.
Correct, but 8's not next. 1 is.
But
when I said go left to right, we just did that one. Next one to do is this one.
Okay, so then that one is 1.
Okay. With multiplicity of what?
2
Okay. And the third 0?
is 8
Multiplicity?
of 6.
Okay. Is this going to cross or tangent? C or T? The first
The first one is gonna tangent.
one. No, it's odd.
No, it's gonna cross. Yeah, okay. So
Second one.
that one's gonna tangent.
Third one.
Tangent as well.
There you go. That's how you do these.
Okay.
And for some reason, I'm not sure why, but an amazingly large number of people miss that 0. I guess you're so used to seeing the 0 as being the opposite sign of this number that if there isn't a number there, you forget to think about it. But don't forget that 0.
Okay.
Okay? And like I said, if there was a 2 there, if that was x squared, then there would be 2 zeros. It'd basically be 0 times 0. So it would be multiplicity of 2. And then that would be
Okay.
it would be hard to have a curve, not really. A curve that was tangent might look like this.
Okay.
There you have 3 zeros, all of them tangents.
Yeah.
All right.
And then my last one is f of x equals x to the 5th, parentheses, x plus 17, and then close them to the 4th.
Okay. What are my zeros and multiplicity?
So the first 0 is 0 with a multiplicity of 5. And then my second 0 is 0 again with a multiplicity of 1.
That's what has to be 0.
Oh, so it's okay. Okay, my next 0 is negative 17 to the 4th multiplicity.
Okay. First one? Cross or tangent?
Crosses.
Second one?
Tangent.
Easy peasy.
Okay.
Okay. And if you forget which is which, even take a linear. You don't have to take a quadratic. If you write the equation y equal x minus 5, well, that starts here, and it has a slope of 1, so it goes like this. It's got 1, 0, and it crosses the x-axis. And clearly, it's only going to have a multiplicity of 1. And in other words, x equals 5 is the only answer. There aren't 2 5s in there. So you can use a linear function to realize that those cross, they're not tangent. When you get to a quadratic function, then you can get something that looks like that, tangent to the curve.
Okay.
Okay?
Yes. Okay. Describe the end behavior of the graph for each function, or for each given function.
Okay.
So this is kind of like going back to review.
Okay.
I don't know. But f of x equals
this is easier than you think. Go ahead.
Yeah, I have a good grasp on what to do. But negative 6x to the 6th power plus, oh wait, not negative 6x, my bad. Just negative x to the 6th power. And then plus
not,
7.
that doesn't have anything to do with end behavior, whether there's a 6 there or a 1.
Okay. And then plus 7x to the 5th minus x to the 3rd plus 9x squared plus 4x plus 8.
What's the question?
So the degree, it's asking for the degree, so the degree would be 6,
Okay.
right? And then the leading coefficient would be -1.
Okay.
But this is where I need some help. So it says f of x, and then an arrow. It's the infinity, negative infinity and positive infinity.
Okay.
So how do I?
X goes to negative infinity. That's the left-hand end behavior. As x left end behavior. As x goes to positive infinity, that's the right-hand end behavior.
So how do I distinguish?
Okay, here's how you do it. First of all, none of those matter. That's why it's easier than you think. And in
It's
fact,
with the exponent.
this doesn't matter. What that number is has nothing to do with it.
Okay.
What I'm going to do is I'm going to substitute negative infinity in here. So, negative, do not drop negative signs. I am substituting negative infinity inside of parentheses, and I'm going to take it to the 6th power. What does that do?
I don't really know.
Well, if you square a negative number, what do you get? A positive or a negative?
Positive.
Okay. And if you take it to any even power, same thing. Doesn't have to be squared. You could take it to the 4th power or the 6th power or the 8th power. Those negatives all turn to a positive.
Positive. Yeah.
So this becomes positive infinity.
And that's for the left-hand behavior?
Hold on, no. And then I still got this negative sign out there that I don't want to drop. So left-hand end behavior is actually negative infinity.
Okay.
Okay? Which means that as x goes to negative infinity, f of x goes towards negative infinity. In other words, you have a graph that's like this. Notice that as I'm going in this direction towards negative infinity on the x-axis, my y value is heading towards that direction, negative infinity. That's what end behavior means.
Okay.
It's what does y go to as x goes to. Now, if we go back and we look at the right-hand end behavior, well, I still got that leading negative sign. And now I'm going to plug in positive infinity inside of parentheses, take it to the 6th power. Always do that first. And notice something very specific here. This exponent does not apply to this negative sign. That negative sign is not inside the parentheses.
Yeah.
The exponent only applies to what's inside the parentheses. So what is infinity to an even power going to be?
Positive infinity.
Correct. Now I throw in the negative sign, so that right-hand end behavior is also negative infinity. So what happens is this thing curves back down there. And now, regardless of which infinity I head to on the x-axis, my y value goes to negative infinity, both over here and over here. That's what it means. That's what end behavior means. Let me test you. Make sure you understand the concept.
Okay.
I'm going to draw a graph, and I want you to tell me the left-hand end behavior and the right-hand end behavior. What's the left hand?
So the left-hand end behavior is negative infinity because it's going down.
Correct.
And then the right-hand end behavior would be positive infinity because it's rising.
Okay. How about this curve here?
Would it be negative infinity and then to positive?
Which way is the y value headed as x goes to negative?
Oh, okay. Okay. So that's positive infinity to another positive infinity.
Correct. In other words, you can get all combinations. You can have the left hand and the right hand both be positive infinity, or both negative infinity, or mixtures of both.
Okay.
But it's always one of those four. And the easiest way to do this, and I'm not sure they're really teaching you this in school, is to do it the way I do it, but I find it works quite nicely to just plug in either positive infinity or negative infinity. I doubt that they do that in your school because they don't really want to perpetuate this belief that infinity is a number. Infinity is not a number. It's a concept. But you can still take negative infinity and square it and turn it into positive infinity.
Okay.
Okay? Or what's negative infinity cubed?
That's a positive infinity.
What's negative 2 cubed?
Negative 2 cubed is it's a negative infinity.
What's negative 2 cubed?
2 times.
No, negative 2 times negative 2 times negative 2. What is that?
That's 8.
Nope, it's negative 8.
Oh my goodness. Okay, it's negative 8.
The point being that if you have a negative number and you take it to an odd power, it stays negative. So if I had negative infinity to the 5th power, it would still stay negative infinity. But if I had negative infinity to the 8th power, it would turn it into positive infinity. That's the only 2 rules you have to know. Negative infinity to the 1 power that's an odd number, so it's negative infinity.
Okay.
Okay? And positive infinities to any power. Once I substitute positive infinity, it doesn't matter whether that's an odd or an even number. The answer is positive infinity. So now it can be negative infinity. We saw how it could be, but that's if that leading variable has a negative in front of it. It'll turn it from positive infinity to negative infinity.
Yeah.
All right. What else?
I have one more.
A lot of wiggle room tonight. I got a 6:30.
Okay. Well, I'm just gonna. This is scientific notation, and I'm not I'm not very good at it. Anyway, so okay. So the first problem I have is in parentheses 8 times 10 to the negative.
Negative what? Britt, I lost audio. I don't know what happened. I cannot hear you anymore. You appear to still be in the session. Uh-oh. I lost my internet connection was what happened. Oh boy.